This is mathheals.com, where you can find more links to math YouTube videos or computer science. Let's take a look at a hypothesis test for population proportion, and we'll do the classical approach by hand. Okay, when observed results are unlikely under the assumption that the null hypothesis is true, we say the result is statistically significant and we reject the null hypothesis. Now these are our steps. First step is write down a shortened version of the claim. Second step, come up with a null and alternate hypothesis. H naught always has equals part on it. 3, see if the claim matches H naught or H1. 4, draw the picture and split alpha into the tails. Now if you got a not equal to on H1, that means you have two tails. If you have a less than, that means you have a left tail. If you have a greater than, that means you have a right tail. Now we're going to find our critical values, and we'll use a standard normal distribution table for that. And then we'll find the test statistic using this formula, where p hat is equal to x over n, and p naught is a number from the claim in decimal form. Then if the test statistic falls in tail, we reject H naught. If the test statistic falls in the main body, we accept H naught. And then we determine the claim based on step 3. So let's look at our first problem. Okay, according to the ABC News in June 2012, 36% of people believe in UFOs in the United States. If a sample of 200, so n is 200, sample of 200 find that 74 of them believe in UFOs, so x is 74. Test claim the percentage that believe in UFOs is greater now at alpha is equal to 5%. So our claim is greater than 36%. And here, something outside. What is it? Maybe nothing. Okay, these are based upon the mean, so both these would be mu. And let's go through our steps. First step, write down a shortened version of the claim. Well, that's this right here. Step 2, come up with a null and alternate hypothesis. H naught always has equals part on it. Well, with greater than here, that implies, of course, the greater than symbol. And that goes on H1, and then this will be less than or equal to. The only symbols you can put on H1 are less than, greater than, or not equal to. The only symbols you can put on H naught are less than or equal to, greater than equal to, or equal to. So when this one is greater than, I knew it had to go down here on the H1. Well, see if your claim matches H naught or H1. Since this is a greater than, this is a greater than, obviously it matches H1. Now one thing I will note here is that this particular textbook we're using only puts equals on H naught. This can be one of these three here, but this is always equals no matter what. I don't like that format of doing these problems because these are opposites of each other. So if this is greater than, opposite is not equal. It's less than or equal to. Step 4, draw the picture. Well, greater than on H1. Greater than on H1 says we're going to have a right tail. It says split alpha into the tails. So alpha is 5%, so I'll put 5%. We only have one tail, so I'll put the entire 5% in this tail, in the right tail. And if that's 5%, then we have 95% here, because it all adds up to 100%. Okay. Step 5, find our critical values. It says use a standard normal distribution table. Standard normal distribution table. Okay, here's our standard normal distribution table. And this is based upon, you can see the picture here, area to the left. Well, the area to the left here is 0.95. So I'm going to look up 0.95 in my middle, or the one that's closest to it. Okay, 0.95. Here's 0.9495, here's 0.9505, so it's halfway in between these. And this is exactly halfway in between these. So I'm going to come over here, it gives us 1.6. And it's halfway in between these, and if I go up here, this is 0.04 and this is 0.05. This gives us a hundredths place. So halfway in between 0.04 and 0.05 is 0.045. So that'd be our critical value. Now, if it's exactly halfway in between two values, then you usually take this. If it isn't exactly halfway in between it, you don't try to do anything. You just take whichever one it's closest to. Okay. Now we need our test statistic. Test statistic is by this formula. Z naught is equal to p hat minus p naught over the square root p naught times 1 minus p naught divided by n. Now p hat is equal to x over n. X was 74, n is 200. So 74 divided by 200 would give us 0.37. So our test statistic, p hat 0.37 minus p naught. P naught is the number off of your claim, which is 0.36, divided by the square root p naught, which is 0.36, times 1 minus p naught, so 1 minus 0.36, divided by n, which was 200. Now when you plug this in a calculator, you want to make sure you put parentheses around the top part. Now the bottom part, we don't need to worry about it, because that's, when it's in one square root, that's considered like one number in terms of the calculator. So I'll put beginning parentheses 0.37 minus 0.36, closing parentheses, divided by second x squared for the square root, 0.36 times beginning parentheses 1 minus 0.36, closing parentheses, divided by n, which is 200. And then press enter. And we get 0.29. Okay. Now it says we have to see where our test statistic falls. Here's our number line. Here's 1.645. 0.29 falls over here somewhere. So for a conclusion, if test statistic falls in the main body, it says accept H naught. So we'll accept H naught, which means we'll reject H1. And our claim matches H1, so whatever we say about H1 is what we say about our claim. So we'll reject our claim. Now, let's compare that. Not that we're doing this by a calculator at all, but if I press stat, go to tests, one prop z test, 0.36, x is 74, n is 200, symbol on H1 is greater than, which I already got highlighted, and then enter. And we get 0.29 46. Of course, I need to know the other number for. But what I'm trying to point out here is that on this particular one, we would get the same answer. On this one, since this is based upon tables, this may be different than technology. So I just wanted to point out, if you're doing it by hand, you may get different answers than if you're doing it by technology, whatever that technology might be. Okay, let's look at our second problem. According to Chicago Tribune in 1990, 74% of teenagers believed in angels. If a sample of 500 teenagers in 500 show that 410 believe in angels, so X is 410, test the claim that percentage is the same at alpha is equal to 10%. And our claim is same as 74%, which same as is equals. Okay. Step 1. Write down a shortened version of the claim. Well, that's what we did here. Step 2. Come up with null and alternate hypothesis. Our null is H naught, so we got mu. What am I doing? P. What if I did that up above? I did. There should be P values. I'm so concerned about what's going on outside that I'm not focusing. There. Wife just got home. I think that's what all the commotion is. Same as. Well, equals goes here, not equals goes here. 0.74 and 0.74. Let's see. See if claim matches H naught or H1. Well, this is equals, so that matches H naught actually. Okay. Draw the picture. Not equal to on H1 says two tails. Not equal to on H1. So we've got two tails. It says split alpha into the tails. Well, alpha is 10%, so we'll put 5% here. We'll put 5% here. If I got 10% in the tails, that means I have 90% in the main body. Okay. Find the critical values. Use the standard normal distribution table. Okay, I'm going to start with this left one here. I look to the area of the left, which is 0.05. So I need to turn to the other one. I'm looking for 0.05 in the middle here, the value closest to it. Here's a 0.0505, and here's a 0.0495. Looks like it's halfway in between these two values. So if I come over here, it's negative 1.6. Now to get our hundreds place, since it's halfway in between this one and this one, I go up, and it's 0.04 and 0.05, which would give me 4 or 5. Now this one, I look up the area to the left, which is a 0.05 and a 0.90, which gives me 0.95. Okay, so 0.95. 0.9, here's a 0.9495 and 0.9505. Come over here is 1.6. Come up here and it gives us the rest of it. So this will be 1.645 using the tables. Next step. Find the test statistic using this formula. Well, we need p hat. P hat is x over n. So we got 410 over 500. So 410 divided by 500, 0.82. Okay, so our test statistic, z naught is equal to p hat minus p naught over the square root of p naught times 1 minus p naught divided by the n. So p hat is 0.82 minus p naught, which is 0.74, divided by 0.74 times 1 minus 0.74, divide by n, which was 500. Again, we have to be careful putting this in. Put parentheses on top when we plug it in the calculator. Okay, so do beginning parentheses 0.82 minus 0.74, closing parentheses divided by second x squared for the square root, 0.74 times beginning parentheses 1 minus 0.74 divided by 500. Enter. And that gives us 4.19. Let me double check that. That's no good. I left out the 4 there. Second, enter. It's always good to double check yourself on these. There we go. 7.4 times 1 minus 7.4. Okay, now that looks good. 4.07 or 4.08. Not that really matters, but this would have gave us the same answer. But it wasn't correct. That looks better. Okay, here's the number line. Here's negative 1.645. Here's positive 1.645. 4.08 would fall over here. So for a conclusion, if test statistic falls in a tail and it falls in the right tail, we reject H naught. So we'll reject H naught, which means we'll accept H1. They're opposites of each other. Now our claim matches H naught. So whatever we say about H naught is what we say about our claim. We rejected H naught, so we'll reject our claim. Let me save this. And population proportion. Let's choose that one. Okay, hypothesis tests for a population proportion. I'm using the classic approach. That's true. T84. That's not true. This is by hand. This will be page 01.pdf. There we go. Let's look at the next problem. Grab a drink here first. Okay, number 3. According to the Chicago Tribune in 1990, 50% of teenagers believe in ESP. If a sample of 400 teenagers, it's amazing how many people believe in things they've never seen, yet things that are right in front of you, like what God has done, people ignore. It's people interesting. Half of teenagers believe in ESP, but not one of them has seen it. Of course, this is back in 1990. Let's see. Tests claim the percentage is different nowadays. So claim is different from, and it says 50%. Okay. Step 1. Write down a shortened version of the claim. We got that. Step 2, come up with a null and alternate hypothesis. These are P's, population proportion, different from, that symbol is a not equal to, which goes on H1. And this would be equals 0.50, 0.50. Different from matches the H1 there. That was to see if claim matches H0 or H1. Step 4, draw the picture. Not equal to on H1. Not equal to on H1 means two tails. Okay, so we're going to have this critical value, and we'll have this critical value. Now, it says split alpha into the tails. We got 1%. I divide that by 2, and I get 0.005. So I put 0.005 here, 0.005 here. And if I got 1% in the tails, that means I put 99% in the main body. Okay, let's find this critical value first. I look at the area to the left, which is 0.005. So, 0.005. Here is 0.0051. Here is 0.0049. So it's halfway in between these two. So I come over here, that's negative 2.5. Let's see what our hundredths should be. We said halfway in between here, so between 0.07 and 0.08. So this would be 575. If I look this one up, this would be 2.575. Two tails for the mean will always do that for your critical values. It'll also do that on proportion problems. Now on chi-square it won't. Okay, so now our test statistic. We need p hat, which is x over n. So we got 190 over 400. So 190 divided by 400 gives us 0.475. And for our test statistic, we got z naught is equal to p hat minus p naught, using this formula, divided by square root of p naught times 1 minus p naught, divided by n. Well, p hat is 0.475 minus p naught, which is 0.50, over square root of 0.50 times 1 minus 0.50 divided by n, which is 400. Again, put parentheses around top if you're going to plug it in. So we got beginning parentheses 4.475 minus 0.50. Closing parentheses divided by second x squared, 0.50 times beginning parentheses 1 minus 0.50, closing parentheses divided by 400. Enter. Negative 1. Well, here's the numbered line. Here's negative 2.575. Here's positive 2.575. Negative 1 falls in here somewhere. Don't know where, but falls in there. So it falls in the main body. So conclusion. If test statistic falls in the main body, it says you accept H naught. Which means we reject H1. And since our claim matches H1, whatever we say about H1 is what we say about our claim, which means we reject our claim. Now I should talk about the word accept. Hopefully I haven't already. I've been creating the same video over and over in this chapter. The word accept is not quite correct. Books will use do not reject. Accept implies a pretty strong wording on that. Like if you got a student that's cheated on a test, and you know they've cheated, but you don't have any proof. You don't accept their innocence. You just do not reject their innocence. You know, it's possible that they did it, but I mean, it's possible they did all their own work. You know, you're almost 100% certain that they didn't. But again, you can't prove it, so you don't accept their innocence. Accept is a really strong word. I like accept and reject because it clicks better with students, being opposites. Let's take a look at our last example. According to the Chicago Tribune in 1990, 29% of teenagers believe in witchcraft, if a sample of 500 teenagers, so N is 500, show that 80 believe in witchcraft, so X is 80. Test the claim the percentage is lower nowadays that alpha is equal to 5%. Okay, so lower than, and it says 29%. Lower than is a less than. Okay, so write down a shortened version of the claim. We did that. Come up with a null and alternate hypothesis. Less than goes here, and this will be greater than or equal to. Step 3, see which one matches. Lower than matches H1. Draw our picture. Less than on H1. Less than on H1 says left tail. So we're going to have one critical value. It says split your alpha into your tails. So we've got 5%. We'll put the entire 5% in left tail, and this will be 95%. Now let's look up critical value here. So we're looking at 0.95 in the middle. Okay. 0.95. Here's 0.9505. Here's 0.9495. It's halfway in between these. So I come over here, it's 1.6. Wait a minute, what am I doing? I'm looking at 0.05, the area to the left. Take a nap, I guess. Okay, let's try it again. 0.05. Here's 0.0505. Here's 0.0495. I go over here, it's negative 1.6. And let's go straight up here. I got 0.04 and 0.05, so halfway in between that, which is 4.5. So critical value is negative 1.645. And we need p hat, which is x over n. Let's see, x is 80 over n, which is 500. So 80 divided by 500, 0.16. Okay, so then our test statistic. We got z naught, which is equal to p hat minus p naught over the square root of p naught times 1 minus p naught divided by n. We're at step, we just did 5, find the critical values using standard normal, and we're finding the test statistic using this formula. Well, p hat we said was 0.16 minus p naught is the number off of our claim, h naught h1, which is 0.29, over square root of 0.29 times 1 minus 0.29 divided by n, which was 500. Again, put parentheses on top. So let's see what this gives us. Beginning parentheses 0.16 minus 0.29. Closing parentheses divided by second x squared for the square root 0.29 times beginning parentheses 1 minus 0.29 closing parentheses divided by 500. Enter. And we get negative 6.41. Okay, so that's our test statistic. Here's the number line. Here's negative 1.645. Let me double check that actually. Okay, looks good. So negative 6.41 would fall over here somewhere. So our conclusion is we reject, test statistic falls in the tail, we reject H naught. So we'll reject H naught, which means we accept H1. They're opposites of each other. Our claim matches H1, so whatever we say about H1 is what we say about our claim. So we'll accept our claim. One last thing I want to mention. If you got a claim that says something about majority, and they don't really give you numbers, they just say a majority believe this, or a majority voted, or whatever. What they're saying is P is greater than 0.50. So that's implied. Let me save this. This is about perfect timing. Resident Evil's getting ready to come on. I've been kind of watching Dawn of the Dead out of the corner of my eye, which is probably why I made a couple mistakes. Okay. Let me save that. Now stop the recorder here. And then stop this other recorder.